FM radio receiver made by us. We'll be explaining the circuit and the block diagram of a simple FM radio receiver. Introduction. What is a radio receiver? It is an electronic device that receives radio waves and converts the information carried by them to a usable form. You'd require FM broadcasting. The frequency range of audible sound is 20 to 20,000 cycles per second. It would correspond to a wavelength of 15,000 meter. Hence, you'd require an antenna of this much order, but you don't find antennas with this much length. So, how does one broadcast the audio signal? That's why we use higher frequency to transmit our signals so that the wavelength is small, and hence we can find a smaller sized antenna for that. Frequency modulation. The audio signal is placed on the carrier signal. The carrier signal is described in A part and the audio signal in B part. And on adding them, we get the D, frequency modulated carrier signal. In this, the frequency varies in accordance with the changes in the amplitude of the audio signal. The basic block diagram of our FM radio receiver is this. First comes the antenna. It intercepts the radio waves that are of the electromagnetic waveform and then converts them to tiny alternating currents that are sent to a circuit. Then comes RF amplifier, which is a tune amplifier that selects and amplifies high frequency signals. It is adjustable so that the selection frequency can be altered, and this is called tuning. This is how you tune between stations. We require a mixer and local oscillator. A local oscillator is used with a mixer to change the frequency of a signal. The frequency conversion process produces the sum and difference frequencies from the frequency of the oscillator and the frequency of the input signal. Then comes IF amplifier and filter. It improves frequency selectivity and extracts signals that are close together of a particular frequency. This is known as filtering. Then a demodulator, which extracts our audio signals, which extracts audio from our signals. And then we need to amplify it. To amplify our audio signals, we would be using AF amplifiers. The circuit diagram that we are using is this one. T1 BJT, it acts as a RF amplifier. The signal from the antenna is tuned and then amplified in it. This is the LC oscillator. C1 and L forms the LC oscillator when L and C1 are placed parallel to each other. The mixer T2 BJT acts as a mixer. It uses a nonlinear component to produce both sum and difference beats frequency signal. The current then passes through R1 and C2, which acts as a band pass filter. It is used to achieve the desired selectivity. It rejects low and high frequencies and allows a band of frequencies to pass through. Demodulator C2 and VR acts as demodulator. It extracts the audio from the signals, which is then amplified through the op-amp. But how would one select a specific frequency? Which component is most important for this purpose? That's the question in our mind. Let's see. This is a circuit. An LC part. LC part is used to tune in our circuits. When they are placed parallel to each other, they form the simplest tuner, where the capacitor or inductor is made to be variable. This creates a resonant circuit which corresponds to an alternating circuit at one frequency. The circuit allows switching between different frequency bands. Thank you.